Are triangles ABC and DEC congruent? Justify your response. Describe a series of rigid motions that would map triangle ABC onto triangle DEC. So there are two different ways that we can think about the first part to this question. We can think about it as if we're dealing with our triangle congruence, trying to find three statements that hold true. That way our triangles are congruent. So one way we can think about it is looking at the parts that are congruent. So we know angle B is congruent to angle E. We know side length BC is congruent to side length EC. And we also know, though there's not tick marks there, that angle BCA is congruent to angle ECD because these angles are vertical angles. So we can also see that we have two pairs of congruent angles and an included side congruent, leaving us with angle side angle, where the side is included in between the two angles. And I can write out my justification statements. So we know the first angles, if we want to talk about them, are angle B and angle E. So we can say angle ABC is congruent to angle DEC. We can also talk about the sides. So we can say line segment BC is congruent to line segment EC. And we can also talk about those vertical angles. So angle BCA is congruent to angle ECD. And now after our three triangle justification statements, we can say that the triangles are congruent. So triangle ABC is congruent to triangle DEC by that justification that we discussed, angle side angle. So this is one way to think about how the triangles are congruent, and this would be a perfectly acceptable justification. Another way that we can think about the triangles being congruent is using this series of rigid motions, that would map the triangles onto one another. So we know that if a preimage goes under a transformation that is a rigid motion, that the preimage and image will remain congruent to each other. So it's first starting to talk about triangle ABC. So let's first consider triangle ABC, and this would be the preimage. So triangle ABC would be our preimage because it's coming first. If everyone sees that, it's the initial image. Being congruent, that would map. So how can we map triangle ABC onto triangle DEC, leaving triangle DEC to be the image? A lot of you joke and call it the post image or the after image. So we're starting with triangle ABC and we want to map it onto triangle DEC. So the big thing when we think about mapping is that we want the corresponding parts to end up on one another. So if we think about the corresponding parts, we see that angle B here, this angle B corresponds with that congruent angle E. We can also see this because B and E are in the same position in that triangle congruence statement. So if we want to map, let me rewrite it here, ABC onto DEC, we can see here that B has to map onto E, that we want A to map onto D, and that C is going to map onto itself. So angle C is going to map onto angle C here. So we can see how we want those pieces that we now have highlighted in a certain color to land onto each other. So in order to do this, we can see a series of rigid motions. So the way we can think about it is rotating the shape where A rotates to D and B rotates to E. So if we were to do this, we can say that we would want to rotate triangle ABC. And the way we want to rotate it is 180 degrees about point C. Point C being the center of rotation. So if you see here, if we spin it about point C, so everything is going to move about point C. If you want to kind of think about it like our axes, it would be like if we were spinning it like this about point C. Mapping, you can say point A onto D, B onto E, and C staying the same, right? And C mapping onto itself and not moving as the center of rotation. You're now able to say that the two triangles are congruent because we know a rotation is a rigid motion. So that is another way that we could have answered the first question. So we can say that triangle ABC is congruent to triangle DEC because a rotation is a rigid motion, which means distance and space is preserved, leaving the pre-image congruent to the image. So that would be another way you could have answered the first part of the problem.